Hello and welcome to this video looking at solutions to the Technia finite element analysis tutorials. I'm going to skip forward from tutorial 2 to tutorial 6 for this video because it introduces a few new interesting topics. So that's looking at analysis of this rubber bellows component, and in this case I'm going to import the geometry from a SOLIDWORKS model and look at combined modeling and simulation on the 3DEXPERIENCE platform when using SOLIDWORKS as the CAD system. So the first thing I've done is to import the geometry from SOLIDWORKS. That takes a little moment, so I've done that already, but just to demonstrate, you choose the import option up here and then configure your import. So SOLIDWORKS part, locate the file on the disk, and choose the configuration to import. In this case, I've created a finite element representation within the SOLIDWORKS part because there are some details that are needed for the finite element model that are not part of the part itself. And if I clicked OK, that would import. I've already done it, so I'll just cancel that. I've also assigned a material to this part. So a rubber type material, and that has a simulation domain, so is suitable for use in the finite element model. So we can see, looking at the geometry, that it's going to be suitable for building an axisymmetric model, which will give us a substantial reduction in solution time usually. To build that, I'm going to switch into the Model Assembly Design app. And we can see now we've switched into Simulia Model Assembly Design app from the CATIA app, so we're starting to do some analysis type work here. I'll choose Automated FEM for building the model and just get rid of that warning box because it's not important. And here you can see under specialized methods of building the model, we've got axisymmetry. So I'll click that and then fill in the dialog box. So the first thing I'm asked for is to select a plane on the plane of axisymmetry. You can see from the robot that the XY plane is suitable for that. And then the origin. Handily, when I've imported from SOLIDWORKS, it's brought in some of the reference geometry for me. So I can choose the origin from the reference elements that were imported, and then the spin axis is going to be, again, if we look at the robot, we can see it's going to be the Y axis. So if I select that, the model geometry is going to be created by abstracting and extracting some geometry from this imported solid body. And the mesh supports, I want to have all of those geometries, so the two platens, top and bottom, and the bellows itself. And I'll leave the initialization method as the default. That's going to choose an element size for me based on some criteria to pick something suitable. I can always adjust it afterwards. And when I click OK, it takes a few seconds, but it's going to create the axisymmetric model for me based on the imported geometry with some abstraction shapes created. So that's done now, and the view switches to the RZ plane, which all looks suitable. If I come down here, it's created nodes and elements, so beam meshes for the platens top and bottom, and a surface quad mesh for the rubber geometry. It's also created some sections. For these shell sections, we can see that they're invalid because it's looking to have a material and a thickness on those. I don't want those because they're going to end up being rigid components in this model. So I'm going to delete those two features. And then when I refresh, the model should update correctly, which it does after a few seconds. So the final thing I now need to do to create the model is to create those rigid abstractions for the top and bottom platens. So if I go into abstraction and choose rigid body, I can apply that now to the beam meshes in turn and specify center of mass as the point, the control point. So select OK on there and click a second, repeat the process for the beam mesh at the other end, and again center of mass, and it automatically chooses a reference point you can see here in dark blue just at the end, which is exactly where I would want it to be. So if I select OK for that, that's the two rigid bodies created. Because they're discrete rigid bodies, they actually need a section, and the easiest thing to do with these is to put a surface section on them. So again, I'll select surface section there and apply that to both of those beam meshes and select OK. And that is my axisymmetric finite element model now complete. In the next video, we'll have a look at building the scenario around that and then how we couple that back into the SOLIDWORKS model if we want to update the geometry and rerun the analysis. Thank you very much for watching.